Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In problem number 91 of chapter 1, Intros Chemistry, Structure and Properties, we've been asked to play the mass in grams for each of the samples. So in order to determine the mass, so the first sample actually is 1.1 times the power 20 atoms. In order to determine the mass, to quickly find the mole and the mole by the molar mass. So since we get the number of atoms, we know that the number of moles times Avogadro's number. So the number of moles here, which I'll represent by n, by Avogadro's number, which I'll represent by Na, gives you the number of atoms. In order to determine the number of moles, which is n here, we just have to divide the number of atoms by Avogadro's number. And we've been given the number of atoms for each of these samples. So once we get the moles, we can then multiply by the molar mass to get the mass. So for the first sample, which is 1.1 times 23 atoms of gold, we find the mass to be equal to, so we take the number of atoms, which is 1.1 times the power 23, divide that by Avogadro's number, 6.02 times 10 to the power 23. So I should include the unit. This is atoms, right? And this is basically atoms per mole. We'll multiply by the molar mass of gold, which is 196.97 grams per mole. We'll actually see what happens here is atoms cancel and moles cancel here. So essentially we're left with grams. So this ends up being approximately 36.0 grams of gold. For the second question, it's essentially the same thing. We have to do this for helium. So to determine the mass, we just have to find the moles and then multiply that by the molar mass of helium. So here we're going to have the number of atoms of helium, 2.82 times 10 to the power 22, and Avogadro's number, 6.02 times 10 to the power 23. Multiply that by the molar mass of helium, which is 6.94 grams per mole. That would essentially give us 0.25 grams. Moving forward, we use a similar thing for lead. We've been given 1.8 times 10 to the power 23 atoms of lead, and actually determine the mass. Mass is going to be equal to finding what the mole is first, multiply by the molar mass, and determine the mole by taking the number of atoms and dividing by Avogadro's number. So we have 1.8 times 10 to the power 23 atoms of lead, and we divide by Avogadro's number, which is 6.02 times 10 to the power 23, multiplied by the molar mass of lead, which is 207.2 grams per mole. And we're going to find out that this gives us approximately 62.0 grams of lead. Lastly, for uranium, we find the mass by taking the number of atoms of uranium, dividing that by Avogadro's number to get our moles, multiply this mole by the molar mass of uranium, which is 238.03. That is essentially going to give us 3.12 grams of uranium.